Today I will be presenting about an introduction of radio wave astronomy. Radio wave astronomy, also known as radio astronomy, is a branch of astronomy that studies celestial objects by detecting and analyzing the radio waves they emit. Unlike visible light, radio waves can penetrate clouds of dust and gaze into space, allowing astronomers to observe regions of the universe that cannot be seen with an optical telescope. By using a specialized instrument called a radio telescope, scientists can investigate stars, galaxies, planets, pulsars, and black holes while learning new information about their composition, structure, and motion.
Hi and Assalamualaikum. I will explain the electromagnetic spectrum. The electromagnetic spectrum is the complete range of electromagnetic radiation. It includes radio wave, microwave, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. These types of radiation differ the wavelength, frequency, and energy. The radio wave have the longest wavelength and the lowest energy, while gamma rays have the shortest wavelength and the highest energy. As shown in the diagram, radio waves are located at the end of the electromagnetic spectrum. This is important because radio astronomy focuses on the radio wave region of the spectrum to study objects and the phenomena in space. Now, I will discuss the properties and characteristics of the radio waves. Radio waves have the longest wavelength in the electromagnetic spectrum. They also have the lowest frequency and lowest energy compared to the other types of electromagnetic radiation. Another important characteristic is that radio wave can travel vast distances through space with very little absorption. In addition, radio wave can penetrate dust and gas clouds that block visible light. Because of these properties, radio telescopes are able to observe regions of space that cannot be seen clearly by optical telescopes. This makes radio wave very useful for studying the universe. In this slide, I will explain the importance of radio wave in astronomy. Radio telescopes detect naturally occurring radio emissions from celestial objects in space. One example is pulsars. Pulsars are rapidly rotating neutron stars that emit regular pulses of radio wave. Radio astronomy is also used to study quasars. Quasars are extremely bright and distant objects that are powered by supermassive black holes. In addition, radio waves help astronomers observe galaxies and interstellar gas clouds. This allows scientists to study the structure and evolution of galaxies. Another important application is the study of the cosmic microwave background, or CMB. This CMB is leftover radiation from the early universe and provides evidence for the Big Bang theory. Overall, radio astronomy helps scientists understand the structure, origin, and evolution of the universe.
Earth astronomy is about observing waves of light. Stars, galaxies, and gas clouds in space emit visible light as well as light from other parts of the electromagnetic spectrum in the form of radio wave, gamma rays, X-ray, and infrared radiation. What are radio telescopes? Radio telescopes collect weak radio light waves, bring it to the focus, amplify it, and make it available for analysis. Radio telescopes was used to study naturally occurring radio light from stars, galaxies, black holes, and other astronomical objects. It also used to transmit and reflect radio light of planetary bodies in our solar system. For fun fact, naturally occurring radio waves are extremely weak by the time they reach us from the space. A cell phone signal is a billion times more powerful than the cosmic waves our telescopes detect. The basic principle behind radio telescopes is surprisingly straightforward but incredibly effective. Radio telescopes come in all shapes and sizes, depending mainly on the radio wavelength they are designed to receive. How does radio telescope work? The curved dish that reflects radio wave to a focal point ranging from meter to sub-millimeter wavelength. Usually, radio waves are reflected by a smaller secondary reflector back down to the center of the dish where it is much more convenient to place feeds and receiver. The captured signals are subsequently amplified and converted into data astronomers can analyze. This process involves sophisticated electronic and signal processing techniques to filter out noise and enhance the clarity of the received signals. It's sort of like listening to faint whispering in a noisy room. The radio telescopes acts as a super refined ear, finely tuned to the whispers of the universe.
We are going to look at the major discoveries. The first one is the cosmic microwave background. It is the afterglow of the Big Bang, and it's one of the strongest pieces of evidence that the universe began about 13.8 billion years ago. Because the radiation is the strongest in the microwave region, radio telescopes can detect and study this. This discovery has helped scientists better understand the origin of our universe. And then next, we have pulsars. It is a rapidly spinning neutron stars that are formed when massive stars explode in supernova. They emit powerful beams of radio wave from their magnetic poles. When the beam passes Earth, radio telescopes detect a pulse of radio waves, which is why they are called pulsars. And then we have quasars. They are extremely bright and distant objects powered by supermassive black holes at the centers of young galaxies. It releases enormous amounts of energy, including strong radio wave. Because of this, quasars can be detected using radio telescopes. Studying quasars helps scientists understand how galaxies and black holes evolved over time. Radio astronomy is not just about observing space, it helps us understand some of the most powerful and mysterious phenomena in the universe. First, it allows scientists to study extreme objects like pulsars, quasars, and black holes, which cannot be clearly seen using visible light because they emit strong radio waves. It is also important for monitoring space weather. By detecting radio signals from the sun, scientists can predict solar storms that may disrupt satellites, GPS systems, and even power grids on Earth. In addition, radio astronomy plays a key role in deep space communication and radar. It helps us communicate with spacecraft traveling far beyond Earth and also allows us to study planets, asteroids, and comets in detail. Finally, it supports the search for extraterrestrial intelligence, where scientists listen for possible signals from advanced civilizations beyond Earth. Overall, radio astronomy connects us to universe in both scientific discovery and practical technology.
Next, we'll be looking at the challenges using radio telescope. The first one is radio frequency interference, RFI. So signals coming from our phones, the Wi-Fi, the TV broadcasts, and satellites can interfere with the radio telescope observations. This will make the weak, poor cosmic signals be difficult to be detected. The second point is atmospheric and environmental effects. So, poor weather condition, water vapor, atmospheric disturbances, and even the radio noises coming from Earth can affect the signal quality. The third point is high cost and maintenance. We all know that to build and operate a large radio telescope, you need to have a good funding. But the equipment must also be maintained and upgraded regularly. The fourth point is huge data processing requirements. So, the modern radio telescope has an enormous data. So, you need to have a powerful computer and storage devices to analyze all that information. Next, we'll be looking at the future developments of radio telescope. The first one is next generation radio telescope. So we've all been hearing about the square kilometer array (SKA) that will provide greater sensitivity and resolution. This will enable observation of more distant and faint objects. The second one is artificial intelligence, AI and machine learning. So AI can process a large number of datasets more efficiently, and this will help detect patterns and discover new astronomical phenomena. The third point is improve interferometry networks. So by linking more telescope across greater distances creates sharper images, and this will help to enhance the study of galaxies, black holes, and other cosmic objects. The last point is space-based radio astronomy. A radio telescope that is placed in space can avoid Earth interference, and this will allow a much clearer observation of the universe.
In conclusion, radio astronomy is an important field of modern astronomy that allows scientists to explore the universe beyond the limitations of visible light observations. Radio telescopes allow researchers to detect and study radio emissions from various celestial objects, leading to important discoveries about the origin, evolution, and structures of the cosmos. As technology continues to improve and advance, radio astronomy will remain a vital tool for expanding our understanding of the universe and uncovering new astronomical phenomena. Thank you for listening.